Good evening, ma'am.
Good evening, Advika and Sridhar.
Good evening, ma'am.
Good evening, ma'am.
Good evening, Devesh. Put on your cameras, everyone.
Good evening, ma'am.
Good evening. Turn on your cameras, please. So we discussed about change in energy in the chemical reaction and change in color. Sridhar, state example of each.
State of energy.
Change in energy in a chemical reaction.
1 minute. Your voice is breaking.
Ma'am, like an example.
Ma'am,
we should tell an example.
Yeah. Advika, you tell.
Ma'am, carbon dioxide plus oxygen.
Okay. Product formed is?
Carbon dioxide plus heat. Yeah, plus heat.
No, if we combine carbon dioxide and oxygen in the product, we'll get carbon dioxide itself.
Okay, ma'am.
Devesh, Siddhant, Ritesh, any change? Okay, Siddhant just joined.
Ma'am, like you're saying some reaction or something?
Dear, example of chemical reaction where change in temperature or change in energy is observed.
Did you say something to me?
Yeah, I've asked examples of a chemical reaction where change of energy is involved, either evolution or absorption of energy.
Ma'am, like change in temperature.
Ma'am, photosynthesis.
Photosynthesis, okay. This is for change in energy. Is this for change in energy, Sritij?
Yes, ma'am.
So energy is absorbed or evolved?
Ma'am, absorb.
Okay. One example Rishit or Aishwarya has to give for chemical reaction where change in color is observed.
Ma'am, when apple is cut open, the iron present in the apple, due to the presence of oxygen, it changes brown.
Great.
Ma'am, can I say?
Good, good. Yeah, please.
Ma'am, oxidation.
Ma'am, adding iodine solution on the potato.
On the potato, okay.
So like the color changes purple.
Ma'am, oxidation.
Oxidation of any substance. Usually metals undergo oxidation reaction.
Like basically iron.
Basically iron, rusting of iron. A brown flaky layer gets accumulated over the iron on
Yes,
the by the attack of air, moisture, and etc. Okay, fine.
Ma'am, can I
Fe
tell
plus
one?
O2 plus H2 only Fe2O3.
Pardon,
Ma'am,
please.
can I tell one? Ma'am, it means like if we add a basic solution to turmeric, it turns into red or a reddish brown.
Great. That is actually a test of pH values, litmus paper test. Great, but good example. Advika, Siddhant, Rishit, and Aishwarya, turn on your cameras. Let's move to the next change. Let me share screen. Hold on. So next is the evolution of gas. Basically, in evolution of gas, I'm telling you the basic reaction when you will combine any acid or any base. Okay, this will lead to give us salt.
Salt, water, carbon dioxide, and heat.
Means gas will also be released in this process. This is a usual and general reaction. In most of the cases, it will happen. So some chemical changes also produce gases. Generally, the gases produced can be carbon dioxide, hydrogen, and ammonia. I told you one test to check whether it is carbon dioxide or hydrogen. If you bring fresh lime soda near to the gas, if it turns milky, then for sure the gas is carbon dioxide. If it does not, then it is not. If you bring a burning matchstick near to the gas where it is evolved, if it burns with a pop sound, then it is hydrogen. Okay, and for ammonia, I'll tell you later. The presence of carbon dioxide can be confirmed. So the test is written along with in the next only. So please don't check for hydrogen, but if you want to check carbon dioxide gas, you can check by bringing a fresh lime soda. This can be done in one more cases when you open the cap of, cold drinks, soft drinks.
Like we get a
Yes.
sound like.
So that gas is also carbon dioxide. You can test it. Just bring fresh lime soda near to it. Now see how you can try with this. If you find it turning milky, then carbon dioxide is confirmed. Okay, and I told you to perform this activity. How many of you have done vinegar and baking soda? No one?
No, actually, like I don't have vinegar in my home, so like I couldn't.
I did it actually. I did it long back. So what I observed is, I put vinegar on the inside the balloon, and
Wait. You put vinegar inside the balloon?
No, sorry, no. Inside one jar. Then I took one balloon, and inside the balloon I put like I took some amount of vinegar. So I also took I took almost like 1 teaspoon of baking soda, and after that I kept the baking soda into the balloon, and then when the in the jar carefully what I did is the top of the balloon carefully I hang it over in the like I kept it like they kept the jar inside the balloon like in the top part, and then suddenly the balloon started like it started it was because of the carbon dioxide gas it started what will I say, I forgot the word. It started like growing.
Inflating. It started inflating.
Yes.
But I asked you to capture this, right? Why you didn't? So other students, I'm asking you, those who have vinegar and baking soda at home, please to perform for not allowing any amount of gas to escape out and to get wasted. You can put 2 teaspoons of baking soda into balloon, fill it in the balloon. Okay, that open part will be obviously upside if you are filling the balloon with baking soda. Take a small bottle or jar, anything which has a narrow mouth, narrow opening. So that you can, why I'm asking you to take narrow opening, so that a balloon can be fixed easily with a rubber band or something, or you can just hold it. Okay. Now in that narrow bottle, about half a cup vinegar you need to take. Now fix the balloon so carefully that don't turn it the covered part upside. No, first try to fix it by letting the other baking soda part, let it be at the downside only. Fix it with a rubber band, okay, and then hold the balloon and hold it like this. Means like you are allowing the baking soda to get mixed into the vinegar. So you will notice that some amount of carbon dioxide will definitely inflate your balloon. And if you want to observe, if you feel that yes, it is little bit getting inflated, and if you want to observe the more good enough inflation, then obviously increase the quantity of both. Okay, and then you can do this thing like shown in the picture to test carbon dioxide gas. Suppose you have balloon is inflated, very carefully take the balloon out and just hold it from the opening that the gas cannot escape. Now in another jar already, please prepare fresh lime soda and then lightly open that opening of the balloon inside the jar in which you have fresh lime soda. So just you can make a short video of the changes observed. It will be very interesting. Okay. Please note down this evolution of gas.
Ma'am,
Ma'am,
can I give
Ma'am, in some fairs like or markets kind of, so some people sell the balloons, so ma'am. So like, do they follow the same process or like, is there any other?
No, the gas filled in the balloon is not always carbon dioxide. Don't get confused with it. No, this is not the only gas we have. We have multiple gases existing in the nature.
Okay. And so like in some balloons like they fly, ma'am. So what's the gas present in those balloons?
Repeat your question.
Like some balloons fly, so like not like the normal balloons. So like what is the gas present in those? Like
helium gas, because you know, out of all other gases, helium gas is very light in nature, means something which has less weight, less mass, tends to go up, if you know this phenomena.
Okay.
One of the example of evolution of gas is, you know, reaction between vinegar and baking soda. In simple words, you can write one example. Second example is this. I think I told you in last class also that carbon dioxide plus lime water. No, not this. I told you that
ma'am, when
limestone whitewashing example I gave you, right?
ma'am, when vinegar and baking soda is mixed, carbon dioxide is evolved, right? That is one of the examples of evolution of gas.
Sorry?
Ma'am, when baking soda and vinegar is mixed, carbon dioxide is evolved. So that's one of the example of evolution of gas.
Yeah, that's what we are discussing. Next example is carbon dioxide. If we mix it with okay, this is a further phenomena of you know, vinegar and baking soda. That's okay, leave it. Second example is of whitewashing. For whitewashing, please note down this. Then I'll write the equation for that whitewash. Second example, you can write this. calcium oxide is the powdered form. When we mix it with water to apply on the walls, it forms calcium hydroxide. When it starts getting when it starts getting solidifying and it is trying to stick and thicken itself on the wall. So for few hours, the heat is continuously get released, which is actually so suffocating when we enter the room immediately after whitewash. So after 2 to 3 days, the gas, escape the room out. Okay. If all of you have written, should I change the slide?
Yes, ma'am.
Everyone, please confirm.
Yes.
Yes, ma'am.
Okay.
Ma'am, what is ammonia?
Ammonia, NH4, is also a type of gas. I just have to snip it. Hold on, give me a minute. Formation of precipitate. In some chemical changes, the product formed separates from the solution and form a different mass of layer. The insoluble solid is called a precipitate. So in any chemical reaction, if you observe that some material has, after chemical reaction has taken place, we need to leave it undisturbed for few seconds or few minutes and observe after that. If you observe anything settle down, okay, and it is visible like out of the solution or separately out of solution, then that is an example of formation of precipitate, one of the sign that a chemical reaction has taken place. So in reaction between copper sulfate and hydrogen sulfide, copper sulfide and sulfuric acid, means combining sulfate and hydrogen, means sulfur and hydrogen, sulfuric acid is obtained. So copper sulfide formed is given out as a precipitate. So you can simply write the reaction in this way. Copper sulfate plus hydrogen sulfide gives out copper sulfide plus sulfuric acid. Okay, and this is the precipitate. And let me tell you one thing, that in any reaction, the elements or the compounds which are combining to undergo a reaction, means anything written on the left side of this arrow sign are known as, any idea? In earlier examples,
Reactants and products.
Reactants, and any elements or compounds that are obtained or we have got after the reaction are called products. Yeah. Okay, so write down the definition and example.
Ma'am, what shall we write the definition of the
Means not the definition, I mean this, that in some chemical changes, the product formed separates from the solution and form a different mass of layer.
Ma'am, can you give one more example for formation of precipitate?
Yeah, I'm thinking about it because, you know, although there are many examples, but all are on the acids or compounds which are not usually found in home. Okay, so I'm trying to think some example with which you people are also familiar with. Otherwise, in laboratory, the teachers do not take class 7 grade to, you know, deal with the chemicals actually. So I'm trying to think. If you can think something, please tell me. Anyone?
I mean, a reaction that is like formation of precipitate.
Pardon?
Like, what should we find? Like the voice was breaking. So what should we find?
You need to think about another example of this precipitation reaction. Formation of precipitate means this is a precipitation reaction.
Okay. Ma'am, potassium chloride and silver nitrate.
That is true, dear, but potassium, chlorine, silver is okay. Nitrate means these are chemical and substances are all new. Otherwise, it is correct. I told you one reaction before this in evolution of gas, that when calcium oxide, the powdered form of white phosh, the powdered packet which we get from the market, we mix it with water and we get calcium hydroxide. So you can write one more example, that when if we allow the carbon dioxide gas to mix with the calcium hydroxide again, what will happen? CaOH twice, CaOH twice. This was the substance which is now accumulated on the.
I sent one example in the chat.
Just hold on. First, let me write this. When you mix this with the carbon dioxide gas back, what you are going to get? You are going to get calcium carbonate, which is a precipitate. The putting of arrow here means it will settle down. It will, like a discrete substance that will be observed. You can write this a white precipitate. So this will be easy to remember as you have now come to know what is calcium hydroxide. Okay, that's the second example of precipitation reaction. Note this down.
Can you look at my example?
Pipes in a home get clogged because precipitates of magnesium and calcium oxide positive themselves. Very good. Great. Correct. Everyone, can you see the example? He sent to everyone. Like in our home, the pipes get clogged and the water is unable to pass through. So yes, some material is observed that has been deposited within the pipes. Correct. That is an example of precipitation reaction. Because water also contain minerals. So, by the attack of oxygen, air, and other factors in the atmosphere, that minerals turn themselves into a precipitate. Fine. Just changing the slide. Yeah, so in addition to new products that we have already learned, the following may accompany a chemical change, that is heat, light, or any other radiation, like in bursting of crackers. Not only the chemical reaction is taking place, but we get the heat, we get the light, we get the sound as well. Okay. Or sometimes the radiation, ultraviolet example for it is given, may be given off or absorbed, like fusion of atoms inside the sun, and ultimately it is emitting ultraviolet rays, which is harmful for our skin. And if you people know, what is there something in the atmosphere that is protecting us from those ultraviolet rays?
The
Ozone layer.
ozone.
Correct. But we have a hole in ozone layer now,
Electromagnet spectrum.
and it is get with time it is getting bigger. Is it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
It is basically present in added in the electromagnet spectrum.
What is present in electromagnets?
Spectrum, like ultraviolet, it's kind of a radiation.
It's
Like we
kind of
have
radiation, but it is spectrum. You cannot say it's spectrum, but yeah, it is a kind of radiation. So sound is also produced. A change in smell is sometimes observed, that is rotting of fruits and vegetables. Color change, already a gas may be formed. So these already done, but you can write the other three changes that can be observed and or that may accompany a chemical change. Once noted, please let me know. Should I change the slide? Shall we proceed?
Yes, ma'am. 1 minute.
Now done? Children, be quick, please.
done.
Just give me a minute. Okay. After chemical reaction, to understand chemical reaction, let us learn about element, molecules, and compounds. Anyone can anyone tell me what are elements? First, only this word element. What are elements? Anyone?
Ma'am, basically elements
Matter.
like they're made up of they contain only one kind of atom.
Okay. Siddhant, can we
Like,
give chance to others, dear?
okay. Now can I send the answer in your
Yeah, you
like
can send.
so,
You can send. Okay. Adrit, you tell me what are elements? Adrit.
Family.
Do you know that every matter, whatever you can see right now in your surrounding is made up of matter. Okay, every state means solid, liquid, and gas are made up of molecules, and molecules are further made up of atom. So atom is the last or the indivisible particle. Means if you try to break something, you break it, you keep breaking it, but after atom you cannot break it further. Okay, so atom is the indivisible particle with which every matter has been made. Okay, so when there is single type of atom, single type means there can be millions of atoms, but their property, their size, their shape, their color, every property is same. That means, I mean, single type of atom. So any substance composed of that single type of atom will be called as element. Means this is pure and such kind of atom is present here. No mixing, no other kind of atom. Okay. Like you can say, we have 20 students in a race. We have 20 students in a 20 child in a society, and all are in DPS, let's say, assume. Okay, then we can say like this is only DPS, so we have to name only one school DPS. So this means single type of element. Single type of atom means element. When we have mixing, we have few students from DPS, few from DAV, few from WIBGYOR, let's say, then now it is formed a compound. Means altogether, if we make all the child sit in one room, then we cannot say it as an element. Getting the difference?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, can we say compounds are mixtures?
Pardon?
Could we say that compounds are mixtures?
Yeah, compounds. Yes, yes. That's what I meant to tell you. So go through the definition, please. Elements mean substances that consist of only one type of atom. This statement is important, only one type of atom, and cannot be broken down into simpler substances, either physically or chemically. Those are elements. So just remember, single. Single means single type of atom. Sorry, single type atom. In simple terms, you can remember. For example, if we say iron, iron is itself a type of matter. So iron has only single type of atoms. It will have millions, billions, trillions of atoms, but only same type. All of their properties will be same. Means properties of all the atoms will be same. Okay. Next, copper. Copper again can have trillions of atoms, but their properties will differ those of iron. But if we open all the copper atoms, their properties will be same. Getting it? Similarly, oxygen, similarly, carbon, similarly, any material like which is liquid also, gas also, solid also, doesn't matter. I'm not talking about state. Solid, liquid, gas, every matter has atoms, and any of these can be elements. Okay. Next, what are compounds?
And the mixture of elements.
Substances in which two or more elements are combined together. So whenever we combine means minimum two, maximum any number. Okay. So when we combine two or more elements chemically in definite proportion, yeah, obviously definite proportion, those are known as compound. If you are mixing, suppose you mix sugar, you mix salt into water, and you stir continuously till they get completely dissolved. It will not be called as compound because there is no definite proportion. Are you getting? Compound example, let's say, all of you know, I guess the formula of water is H2O. That means two atoms of hydrogen, two atoms of hydrogen, okay, and single atom of oxygen. This is a definite proportion, and you can means anywhere wherever water is present, water always have one molecule of water will always have two atoms of hydrogen and one atom of oxygen. This is a definite proportion. This will be called as a compound, not the mixture of chalk and water, not the mixture of vinegar and baking soda. No, these will not be a compound. These can be called as mixtures. Okay.
Ma'am, so like in water, hydrogen is diatomic.
Sorry?
And so like hydrogen is diatomic in water. Okay.
Another example, if I give you, is carbon dioxide, okay, which is the gas mainly responsible for global warming. CO2. That means single atom of carbon is required to behave, to show the property of carbon dioxide. Single atom of carbon, when it combines with 2 atoms of oxygen, this molecule will be known as a compound, and trillions of molecules of CO2 will also behave in the same way as single molecule will behave. Got it?
Ma'am, can we say NaCl?
NaCl, you can say, correct. One single atom of Na means sodium, and single atom of chlorine, when they combine, they form it forms a compound. Good, great example. One atom of sodium. You know what is Na? Sodium, a type of metal.
Yes, sir.
And one atom of chlorine, a type of non-metal.
Ma'am, sodium is an element.
Yeah, dear, everything, anything you can see in your surrounding is made up of either compounds or mixtures or elements. I'm saying anything they are made up of. So they have been derived out from any element, and all the atoms that are existing, which we are using in our home made products and all the furniture and anything. If each and every material is existing in the nature only, right? Nature is only giving us, and nature is only helping us to survive. Who are we to create something? Got it? Difference between elements and compounds?
Yes, sir.
Let's quickly, okay, do one thing, because I don't want to rush. So do one thing, just note down elements and mixture, elements and compounds. Mixture will be continuing in the next class. Please note down all the examples of, for elements, I'm telling you the example. Elements can be classified into 2 broad groups, metals and non-metals. An example of atom, please write down. Okay, simple, write down the words. Sodium, let's say carbon, the things which you are already familiar with. Tell me more example of elements. Yeah, iron.
Calcium.
Iron, copper, oxygen, and carbon are already written. Sorry.
And potassium.
Potassium. Chlorine. You must be knowing chlorine, because chlorine has its use in, disinfectant. It is a disinfectant.
Einsteinium.
Huh?
Einsteinium.
Oh my God, you are telling radioactive elements. Great. Okay, you can write down, no worries. Please note this down quickly.
Ma'am, our teacher told to remember the whole periodic table.
Oh, it's like that. Seriously.
Yeah. She told it any formula can come in exam, you have to write.
My dear, at the level of grade 7.
I have to only memorize the first 20.
It's not about memorizing anything, what I feel personally. It's about knowing how to see, like this, we have somewhat about 114 or 118 elements. Can you remember them in that too in series?
Ma'am, this is a song for her. Ma'am, this is a song for the whole periodic table.
That's not only a song, there are many different ways people have created to remember. Why to cram anything?
Ma'am, there's
That's
going to
your
be
choice.
Ma'am, you wrote sodium, carbon, potassium, chlorine for examples of elements. Okay, ma'am. Scientists are going to find the 119th element.
Yeah. Noted.
And like our mom told that you are grade 7, you should know everything. Your knowledge should be high. So you should remember the whole periodic table. And I will ask any element or any compound from the periodic table, and you have to write it. And if you write wrong, I'll cut marks. I don't care. You have to remember the whole periodic table.
Okay.
Ma'am, people who are done can leave.
People?
Ma'am, if you're done noting down, can we leave?
Yeah, oh yeah, sure. Please confirm everyone else. Have all of you noted down?
Yes, ma'am. Yes, ma'am.
Sure, should I stop sharing?
1 second, still writing.
Okay.
Bye, ma'am.
Bye. Have a nice
Ma'am, I'm done.
Okay.
Ma'am.
Thank you, ma'am. Bye, ma'am.
Fine, thank you. Bye.